Hey kids, welcome to lesson 7.6, sorting algorithms. There are many sorting algorithms to put an array or an array list element in alphabetical or numerical order. We are going to show these algorithms below. For the exam, you need to know 3 of them. Selection sort, that is, select the smallest item from the current location it's on to the end of the array and swap it with the value at the current position. Do this from index 0 to the array length minus 2. And we'll get to that in a second. You don't have to process the last element in the array. It'll already be sorted when you compare the prior element to the last element. All that minus 2 is saying that, kids, the last one should be fine. We don't have to worry about it. We can save that time and efficiency. Insertion sort. Insert the next unsorted element in the already sorted part of the array by moving larger values to the right. Start at index 1 and loop through the entire array. Those two are going to be covered in this video, kids. Towards the end, one of the last videos we're going to do here is going to be that of a merge sort. That breaks the elements into 2 parts and recursively sorts each part. An array of 1 items is sorted, the base case, then merge the 2 sorted arrays into 1. And like I said, merge sort will be covered in Unit 10, so we're not going to worry about that right now. Selection sort, the selection sort that you need to know for the exam, starts at index 0 and looks through the entire array, keeping track of the index of the smallest value in the array, and then swaps the value at the smallest index with the value at index 0. Well, then it does the same thing for index 1, well, then 2, and then so on until it reaches the length of the array minus 1. At that point, the array is sorted in ascending order. Essentially, kids, what it's doing here is just comparing 2 numbers and moving the smallest over. And it just keeps doing that until it is all sorted the right way. And this video, if you do any kind of computer science beyond this, you'll see this video a million times, kids. We're not going to play it here, but it goes through a fancy dance of a selection sort. And also we have another video here that does a good job on explaining the selection sort in 3 minutes. Really, I'd recommend just watching this one. You're going to see this one forever, but both explain what a selection sort is. And again, kids, you're going to have to know this piece of code right here and how it works. And that's what we're here to do today, kids. Here's your identifiers, kids. This is going to be a lot easier to do in the Java visualizer. So let's jump over there and then we can talk about these things right here. Let's go ahead and go through this code here. And kids, really, we just have 2 loops, 1 outer loop that's setting our initial minimum. We have an inner loop that's going to compare the rest of the numbers at the index. And then we're going to compare at those indexes, which one is smaller. And if it is, we're going to flop them. And then that's going to become our new index spot. The numbers we are using are here. We're basically going to create a new array and then put it through our sorting method. Well, let's go ahead and give it a try. Here we are creating our array. Now we're in our outer loop. And you can see J is at position 0. Well, that is a 3. Now we're going to go to our inner loop, and that should compare 1 moving forward. Is a 3 less than 86? It is. Really, we should get to 20. It should say no, and we should flip-flop the 2. Let's see if that's what happens. Now we're at index 2. And you can see the minimum index was actually at 2 here. Means we're going to flop those 2 positions. And now 3 goes to where negative 20 is. Now we're going to do the same thing here with position 1. So we moved over. 3 went through everything, found the lowest, moved it over. Now we're going to do our minimum index at 1 moving over. Negative 20 is going to be less than all these, so we should go through all of them. Now we are going to move over to position 2. And that will be our 3. So now we're over at 3 here. 3 is less than 86, so we're going to flip-flop it. And there you see that right there. We're going to rinse and repeat, kids. And we're just comparing these numbers, whatever index we're at for our outer loop, with that number in the inner loop. And you can see every time it finds one that is less than, it's just flip-flopping those exact ones. You can see where this can be a little inefficient. And at the end there, I flew right past it, kids. You can see it printed off whatever the sorted list was, and there you go. That was our list, just flip-flopping them over. So picks a number, compares them to each moving over. If it finds one that's less than it, flip-flops it, continues it over. Pretty neat, kids. Let's jump back to Runestone. Here is that program. Let's just go ahead and hit run. And you can see it sorted it down. And we can add any numbers you want. And if we go ahead and run it, whoop, make sure you don't have too many commas in there, kids. It sorted the numbers. So it doesn't matter how many we add, it's still doing the same thing. Taking a number at the index, and then the inner is just comparing it. If it finds one that's less, it's swapping, or rinse and repeat, kids. Pretty neat. We have a question. Under what condition will selection sort execute faster? If the data is already sorted. If the data is already sorted in ascending order. If the data is already sorted in descending order. It'll take the same amount of time to execute no matter what. Well, kids, as you saw, it's always going to step through no matter what. So it's always going to take the same amount of time. This method should sort the numbers in the passed array into ascending order, but it does not work. Which of the following lines is wrong? Well, looking through this right here, we have my outer loop. It starts at -1. We're going to progress through. We're making our new minimum index and looking for it. My for loop right here goes through those elements starting at the length. And kids, I think my issue is right here. Remember, we have a set index for our outer, and then we're comparing against that index for each one. So this one has to be a +1. If the element at k is less than the minimum index, we're going to swap them out. And there we do that. So I think it's a line C, kids. I think it should be a +1 on that. Hey, there we are. Insertion sorts. The insertion sort that you need to know for the exam started at index 1 and inserts the value at index 1 into its correct place in the already sorted part, a little part to the left of the current index. It moves any value larger than the value stored in temp to the right until it either finds the appropriate place to put temp or gets to the front of the array. Again, kids, you're going to see this video throughout your computer science career. I don't want to be the teacher that ruins it for you. So watch it on your own time or any of the other 45 classes you are going to take in computer science. I do recommend this insertion sort video right here. And what part do you have to know? Well, right here is the code, kids. So this is what you're going to have to memorize for the exam and understand how it works. So this is the important part. Here's your identifiers, kids. This is going to be a lot easier to do in the Java visualizer. So let's jump over there and then we can talk about these things right here. And how do we identify an insertion sort? Well, we want an outer loop that starts at 1 and loops through the entire array. Well, that should be line 7 right here. Sorting the element value at the outer loop index in temp. Well, that should be line 9 right there. Setting the possible index to the outer loop index. That means we could set it right there. An inner while loop that loops while the possible index is greater than 0 and the value in temp is less than the value at that possible index, -1. Well, kids, that is line 11 right there. Set the value to possible index to the 1 to the left. The 1 at the possible index, -1. Well, that's that part right there. Decrement the possible index. Well, that should be that one right there. When the while loop ends, set the value and possible index to a temp. And that's one right there. So kids, what's this basically going to do? Well, it's going to work left to right. It's going to examine each item and compare it to the items on its left, and then insert the item in the correct position in the array. The array will form sorted and unsorted partitions kind of as we go along, and we'll see it here, kids. Basically, kids, this is just flip-flopping things down left. Let's see it work here. We have the code. Again, kids, best just to memorize this. And we have an array that we're going to create and then a print off. Let's see how it works. So our array is created. We're in our for loop here. And you can see we're going to compare 3 first to the left. There's nothing to the left, so that's going to become sorted. Then we're going to move on to 86. And 86 now, it's going to compare to the left. Well, yeah, that's fine. So that's going to become sorted. Then we're going to move on to -20, and then we're going to start comparing it. And then we're going to move that down. So is -20 less than 86? Yep, we're going to swap it. And then we're going to do the same thing. Is it less than 3? It is. And we're going to swap it. So there you go. You can see it is less than that. Moved over. And then we move it over to the end there. So it's just moving down as we go. And then this becomes sorted. All this becomes sorted. And then this one becomes sorted. Now we're at 14. And we're just going to flip-flop 86 and 14 here. And then we're going to do the same thing to 40 in 86. That's all sorted now. At that point, our array sorting is complete. And then we're going to return those numbers sorted through. Pretty interesting. Basically, we're always looking to the left. If it's smaller, we're swapping it out. Let's head back to Runestone, kids. Here is the same thing. You can save and run and see it work there. And the same thing. We can add more numbers here. And run it. And you can see it'll always sort it down. Pretty neat, kids. Under what condition will an insert sort execute faster? Well, kids, think of it this way. It's always comparing to the one on the left. So if it's already in an ascending order, it's going to be right. So on this one, I think it is A. Well, this method should sort the numbers in the passed array into ascending order, but it does not work. Which of the following lines is wrong? Well, we're starting off with our for loop here. And remember, it has to go through the entire array. This one is stopping one short. So that's an issue right there, kids. The rest of it, we have our while loop, setting it the possible indexes to each other and decrementing. Everything else looks good. Except that first line, kids, I think it should be A. Yay, oh, we are right. Selection sort and insertion sort have similar runtimes. They both have nested loops that run through the data of size n, approximately n squared times. However, they perform differently on some data. In the active code window for selection sort and insertion sort above, add in a counter and increment it inside the inner loop to count the number of iterations. Add in a print statement that will print the counter value after the loops. Run the code and see how many times it goes. And it looks like we have some numbers to run here after we put in a counter. Well, that's not too bad, kids. Let's go up to our first one here. And if we want to put a counter, I know it has to be in my method. So the first thing I have to do is I'll declare that, right, kids? We're just going to do a counter right there. And remember, we had to count on this one on the inner loop. And where's my inner loop on this one? Well, that's my outer, that's my inner. So I'm going to do it right before my if statement here and just do counter plus plus. Then I need to do a print, and I'm just going to do it right here. And inside here, let's put selection counter, and we'll do one of these and a plus a counter, and that should give me how many times it went through. Well, let's go ahead and hit run. 28 times. So it had to go through 28 times for that to work on this data set of numbers. Pretty interesting, kids. Let's go ahead and handle the second one here. We have to do the same thing. Counter, where does that have to be? Well, outside my loop. Int counter 0. And this one had to be inside the inner loop. And my inner loop was right here, while. I'm going to go down here and do a counter plus plus, and then we can print off right here. And this one is, insertion sort. And this one, how many times? Now, when I hit save and run, we should see how many times it took to sort this, 13. And you can see with a data set of similar size, it took significantly fewer steps. Does it really matter with this much? No, kids, but when you start talking about millions and trillions, those little steps add up. Selection sort and insertion sort are iterative sorting algorithms that can be used to sort elements in an array or array list. Informal runtime comparisons of program code segments can be made using statement execution counts. And kids, that's it, what you have to do for here. I'm going to have a separate Google document for you to fill out. Do not do the one on Runestone. But hopefully this video was helpful in helping you complete that assignment. As always, kids, if you have any questions, let me know. Otherwise, I'll see you on the next video. See you later, kids. Bye. Bye.